How can you prove two lines are actually parallel? In this lesson, we are going to show you how to prove lines are parallel by using a transversal and evaluating the angles. What are parallel lines? Two lines are parallel if they never meet and are always the same distance apart. Both lines must be coplanar, which means in the same plane. To use geometric shorthand, we write the symbol for parallel lines as two tiny parallel lines, like this. JI is parallel to NX. What is a transversal? A line cutting across another line is a transversal. When cutting across parallel lines, the transversal creates 8 angles. Those 8 angles can be sorted out into pairs. Let's label the angles. These 8 angles are corresponding angles, alternate interior angles, alternate exterior angles, supplementary angles. How do we prove lines are parallel? Every one of these has a postulate or theorem that can be used to prove the two lines MA and ZE are parallel. Let's go over each of them. The corresponding angles postulate states that parallel lines cut by a transversal yield congruent corresponding angles. We want the converse of that, or the same idea, the other way around. If a transversal cuts across two lines to form two congruent corresponding angles, then the two lines are parallel. To know if we have two corresponding angles that are congruent, we need to know what corresponding angles are. In our drawing, transversal OH sliced through lines MA and ZE, leaving behind 8 angles. Each slicing created an intersection. If one angle at an intersection is the same as another angle in the same position in the other intersection, then the two lines must be parallel. Two angles are corresponding if they are in matching positions in both intersections. The corresponding angles are angle B and angle G, angle C and angle J, angle F and angle L, angle D and angle K. If you check only a single pair of corresponding angles and they are equal, then the two lines are parallel. Let's look at the alternate angles. Alternate angles as a group subdivide into alternate interior angles and alternate exterior angles. Exterior angles lie outside the open space between the two lines suspected to be parallel. Interior angles lie within that open space between the two question lines. In our drawing, angle B, angle C, angle K, and angle L are exterior angles. Angle D, angle F, angle G, and angle J are the 4 interior angles. Alternate angles appear on either side of the transversal. They cannot, by definition, be on the same side of the transversal. In our drawing, angle B is an alternate exterior angle with angle L. Angle D is an alternate interior angle with angle J. Can you find another pair of alternate exterior angles and another pair of alternate interior angles? Here are both pairs of alternate exterior angles, angle B and angle L, angle C and angle K. And here are both pairs of alternate interior angles, angle D and angle J, angle F and angle G. Now let's prove lines are parallel with the alternate exterior angles. If just one of our two pairs of alternate exterior angles are equal, then the two lines are parallel because of the alternate exterior angle converse theorem, which says, if two lines are cut by a transversal and the alternate exterior angles are equal, then the two lines are parallel. Angles can be equal or congruent. You can replace the word equal in both theorems with congruent, without affecting the theorem. So, if angle B and angle L are congruent, the lines are parallel. You could also only check angle C and angle K. If they are congruent, the lines are parallel. You need only check one pair. Just like the exterior angles, the 4 interior angles have a theorem and converse of the theorem. We are interested in the alternate interior angle converse theorem. If two lines are cut by a transversal and the alternate interior angles are equal or congruent, then the two lines are parallel. In our drawing, if angle D is congruent with angle J, lines MA and ZE are parallel, or if angle F is equal to angle G, the lines are parallel. Again, you need only check one pair of alternate interior angles. What about supplementary angles? Supplementary angles add to 180 degrees. Supplementary angles create straight lines, so when the transversal cuts across a line, it leaves 4 supplementary angles. When a transversal cuts across lines suspected of being parallel, you might think it only creates 8 supplementary angles because you doubled the number of lines. Not true. It creates 12. Around the top intersection, around the bottom intersection. Those should have been obvious, but did you catch these 4 other supplementary angles? These 4 pairs are supplementary because the transversal creates identical intersections for both lines, only if the lines are parallel. The last 2 supplementary angles are interior angle pairs, called consecutive interior angles. The consecutive interior angle converse theorem states that if 2 lines are cut by a transversal and the consecutive interior angles are supplementary, then the 2 lines are parallel. As you may suspect, if a converse theorem exists for consecutive interior angles, it must also exist for consecutive exterior angles. Consecutive exterior angle converse theorem states that if 2 lines are cut by a transversal and the consecutive exterior angles are supplementary, then the 2 lines are parallel. Consecutive exterior angles have to be on the same side of the transversal and on the outside of the parallel lines. So, in our drawing, only these consecutive exterior angles are supplementary. Keep in mind, just checking any one of them proves the 2 lines are parallel.